Welcome back. Welcome back to the laboratories of Blue World Crete. If you hear any background noises, we got some thunder going outside, and it's really a storm out there in the Atlantic Ocean. We're hoping that it doesn't come this way. Welcome back for the rest of for the next installment in the series of lectures we've given on Blue World Crete and the technologies that we have discovered here. Remember, the Blue World Crete is a company, a technology company, which is interested in changing the world through changing the way we produce building materials. We've talked about progress in the past series, and we've talked about that progress really means more buildings, more structures, and at the volume of the planet's growth, progress right now, we're beginning to choke ourselves with the materials that we're building because they, in their manufacture, are polluting our Earth. So the focus here at Blue World Crete is to develop materials, material sciences that in which we can change the paradigm of our polluting ourselves through the products that we produce for building materials. We've talked about Geo-Blue 2, and we've talked about it as a cementous product, a product that can serve as an alternative to Portland cement. What we haven't told you is what something like this costs relative to Portland cement. If we were comparing white Portland cement to Geo-Blue 2, you're going to find that we're about maybe 10 to 20% under that price. Depending upon where we're talking in the world, the economic model is much more economically appealing than it is for Portland, because we're not relying on fossil fuels and not subject to the up and down world of the petrochemical field. We've talked about Geo-Blue Crete as a covalent bonding material. And what I wanted to show you today is very interesting. This kind of happened by accident. What I have in my hand at this moment is mortar, which is made out of Geo-Blue 2, and what you can see inside the mortar itself that we've cut away here is our peanut shells, and you can better see it if I move this to the top where the peanut shells are more obvious and not really bathed in the mortar material of Geo-Blue Crete 2. What has happened is that the wood has crystallized. The covalent bonding material has bonded with the cellulose material and basically formed a crystalline type of wood. And basically, if we were talking about the giant woods in the petrified forest, and we're talking about that wood is crystal and now stone, this chemical process of making the Geo-Blue Crete 2 and 3, this process, this bonding agent that we add, in essence creates a petrified substance out of the peanut shells, and would do the same thing with wood. When we looked at the material that we have named Geo-Blue wood, okay, we're seeing that cellulose material could be anything. Could be peanut shells, could be straw, could be grass, could be hay, could be cotton. In the case of this particular material, it's cotton. I don't know if you can see, but we're going to try and catch an edge here. And if you see right up over here, right on the edge, you'll see those very fine strands, those hair-like strands standing up. And that's cotton, ladies and gentlemen. And the cotton that's embedded in here has become very crystal and has helped to form a very strong matrix, a structure within the polymer itself, which now created a very hard wood-like substance. Let me just drop it so you can hear it. Okay, we're talking about a piece of wood here, okay, and that can be nailed, it can be screwed, it can be bolted. This, ladies and gentlemen, is a future of our forests. This is going to stop the cutting down of trees unnecessarily. And here we have a safe product, okay, which came from a very simple thing that happened. My liking peanuts. And when I saw the crystallization that happened with the peanut shell, I began to understand that the catalytic material that we were dealing with could be used in order to create something like this. Ladies and gentlemen, let me talk about the company for a moment. I've talked to you something about the products. I've talked to you about the encapsulation properties, the fact that we can take toxic material and we can turn it into something which is no longer toxic through covalent bonding. I've talked to you, for example, about heat and the fact that we can take a substance and we can heat it up to 3,000 degrees Celsius and we're not going to have any popping or explosions as we would with Portland. I've talked to you about the fact that we can mix with salt water and we can mix with seashells and still have a product that's over 5,000 psi. Okay, I've talked to you, ladies and gentlemen, about the fact that the product really can be used for earth stabilization, in which we take the product and we basically can mix it with regular land. In the case of this product, this was earth from Costa Rica, just mixed with our catalytic material. We've talked about many things about the product, including the fact that we could coat it, we could coat metal with it, use it as a coating material. We have a hydroelectric plant in Oregon right now, in which what we're doing is we're coating the inside of their stacks to protect it from the abuse of chemicals and the intense heat as smoke goes up those flumes. And we've showed you that if you leave rebar unattended, unprotected, and it is the inner structure of concrete, that it's going to corrode, and as it corrodes because of the flow of electrons being exacerbated in an acid-like type situation versus an alkaline type situation. Okay, we've told you that it has tensile strength in 360 degrees squared in every single direction, just like this cement ball just shows you. Looks like a rubber ball, ladies and gentlemen, but it is cement. Absolutely cement. Watch it. Cement. Okay. We can take that same product, we can put colors and tints into it, we can make cabinet tops, we can make flooring material, we can make roofing material. Ladies and gentlemen, we have a material here, a building material here. We have a building material here that can stop us from adding toxins to our water stream, polluting our air with more carbon dioxide. The economical model is less than it would be for Portland. The availability of the materials here is extremely available. There's no reason, other than keeping the status quo the same. I guess that's what status quo means. Okay? There's no reason why a businessman can't understand that it's time to change the way we build things. There's no reason why an architect can't understand that it's time to change the way we build things. There's no reason for an engineer not to understand that it's time for us to change. And you know what? There's no reason for politicians to not make better laws that protect the environment. And there's no reason why the public should stand by and have to breathe air, okay, that pollutes them. And there's no reason that our children and our future children should have to suffer because we've polluted our world. I've given you science as the answer. I've given you a substance of the two major questions in our environment. Wood, concrete. A way to make them, to make superior products, high performance products, without polluting our world, without having large carbon footprints, and without knocking down our oxygen producers. When I went to school, I was told that whatever our problems are in this world, for the most part, science is there to help find an answer. We at Blue World Crete have found some very important answers for you. It's time you came to us and applied the sciences that we have here. Thank you for your attention. Thank you for attending these series of lectures.